Okay guys, welcome to this quick guide on the fundamental theorem of calculus. So the fundamental theorem of calculus lets us figure out the exact area under the curve of a graph. So if we have the graph right here and we're trying to figure out the area under the curve from point A to point B, that kind of looks like this, right? So this is just a random f of x, and this is point A, this is point B. The fundamental theorem of calculus lets us figure out the exact area under the curve using infinitely small rectangles, right? Let's just figure out the exact area under the curve. So the way you figure this out is you take the antiderivative of the graph and you plug in point B minus the antiderivative at point A. Okay, so let's just do some practice problems and hopefully that'll make some sense. So let's take let's find the area under the curve of the graph of x squared from the point 2 to point 4. So x squared, right, we know looks something like that. This can be point 2, this can be point 4. And we're trying to figure out this exact area, right? So before we'd use rectangles or trapezoids or whatever, but now we're going to use the fundamental theorem of calculus. So first we need to figure out the antiderivative of x squared. So it has to be something like x cubed, and then remember working backwards, 3 times this 3 times something equals this coefficient, which is 1, so it's 3. Okay? So now that we know that, I'm just going to lasso this out of here. Okay, so then now that we know that, it's x cubed over 3 is the antiderivative, right, the big F. We need to figure out the antiderivative at point B. So point B is the 4, so it's 4 cubed over 3 minus, and then this is at point A, so it's 2 cubed over 3. Okay, so this is once you figure out this is the exact area under the curve for there. If we plug that into our calculator, what are we going to get? We're going to get that this equals 18.6 repeated. Okay, so that is the exact area under the curve for the graph of x squared from the points 2 to point 4. Let's take a look at one more practice problem, and then you guys got the idea. The hardest part about these is just figuring out the antiderivative. The fundamental theorem itself is pretty, as you guys can see, it's not that bad. Let's find the area under the curve of the graph 1/4 x to the 4th power from the point 3 to the point 5, right? X equals 3 to x equals 5. And I think this is what the graph will look like. I actually haven't graphed it, but it looks something like that, right? Kind of like, so then we can figure out the exact area under the curve from these points. First, what do we have to do? We have to figure out the antiderivative. So remember, you always, when you're figuring out the antiderivative, you just add 1. So then 5 times what equals 1 over 4? 5 times 1 over 20. Okay, so now that we have the antiderivative, we can just plug in 5 to the 5th power over 20 minus 3 to the 5th power over 20. Plug that into your calculator. What are you going to get? You're going to get 136. So that is the area under the curve of the graph 1/4 x to the 4th power from the area from point 3 to point 5. And I need to make this really quick distinction here. So usually when you antiderive, you have to add a plus c, right, a constant. But because in the fundamental theorem of calculus, you're subtracting here, effectively what you would get if you antiderive x squared, right, as we remember, it's x cubed over 3. It'd usually be plus c. But then when we did it, right, if you think about from 2 to 4, the plus c's eventually get subtracted by each other, right? And when you subtract a constant by itself, what do you get? 0. So that's why you don't really, when you're doing fundamental theorem of calculus, you never have to worry about this constant. So sometimes it might be helpful to write it, sometimes it doesn't. In this quick guide, I didn't write it. Didn't want to confuse anyone. Okay, hope I helped. Like, subscribe. Thank you.